Hey everyone, so now we're moving on to question 10. Um, the question reads, oops, a ball of mass M rolls in a bowl bolted on a cart. The ball and the cart move together and have a combined mass mc, as shown in the figure. Initially, the cart moves to the right with a speed v naught with respect to the ground, while the ball is at rest with respect to the cart. The ball then slides down to the bottom of the bowl. When it reaches the bottom bowl, it moves with velocity vb with respect to the cart. At this instant, how fast is the cart moving with respect to the ground? So for this question, the basic idea here is to use conservation of momentum. Specifically, if we remember that, like it might not really seem obvious why momentum, like it's not really a collision going on right here, but it's more so of that conservation. There's a conservation of the center mass, right? Obviously, there's always going to be conservation of center mass. And this question, it's more, it's better for us to consider the conservation of velocity. So remember what's the equation for the center mass is going to be the mass times x1 plus the mass times x2, blah, 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 to, yeah, all the masses, right? This is the equation for the center mass, but if we instead look at the velocity, they take the time derivative, so velocity of mass is equal to m1, and then the time derivative of x is just v, right, plus m2v, and this is actually just another restatement of conservation of momentum, as you can see. So basically that's what we're doing. We're looking at momentum because of this fact. So let's first look at the momentum before the cart, before anything happens. Before we start though, it's really important to note that this question you can get really messed up because you don't keep track of your reference frame. So let's make this a hard set right now. Let's set the reference frame as a laboratory frame. Okay, so what is the momentum initially? The momentum is c plus the small mass, okay, just the total mass times the velocity naught. They're both moving at that same velocity, okay. And now what's the momentum final? Well, momentum final is what is the velocity of this m? Well, small m, we know that it has a velocity vb with respect to the cart at the final instance, okay. So then you have mvb plus, so remember vb is with respect to the cart. So then if we want it, because remember we're in the laboratory reference frame, so that means we need to also add the velocity of the cart. But this is not velocity naught. We have to be very careful because the velocity, as you can imagine, the velocity of the cart slows down as the velocity of this ball speeds up because of the conservation as shown right here. Conservation of momentum and also conservation of the velocity of the center of mass. So we'll call this velocity final of the cart, and that's what we're looking for. How fast is the cart moving with respect to the ground? So this is actually what we want. Okay, and then we also add the momentum of the cart in the final position, which is just the mass of the cart times the velocity of the cart in this final position. So we simplify this down a little bit. We get mc plus m v naught, and then we're going to distribute the mass, so minus v, crap. mvb, and that's equal to mvf plus mcvf, and we can isolate vf, so this is mc plus m. So final answer is going to be mc plus m v naught minus mvb over mc plus m, and that actually is this.